This is a screen recording to assist you in using Microsoft Excel to support your probability distribution investigation. We want to, in particular, do the simulation using Excel, and so we're going to talk about how to do that. Let's open up the Microsoft Excel workbook, the new workbook, and as we do, I think we can go and go to Normal View, and it's also going to be important, I think, to view the formula bar so that you can see what's going on as we proceed. Now in this simulation we are trying to simulate the random placement of 4 different cards in boxes and choosing a box and which card do we get. So we want to generate, we want to access a random number, and in order to do that we're going to start with a function. In Excel all functions start with an equals sign. So we're going to choose equals rand between. And because there are 4 cards, we're interested in rand between 1 and 4. So that generates, in this case, the number 1. But in fact, it's not the number 1. As you can see up top, it is a dynamic function, rand between. What that means is it will change every time we do a new operation. Now the first part of this exercise is to do 20 trials. We don't know how many boxes we're going to have to open in order to get our desired card. So I'm going to go ahead and let each of these rows from 2 to 21 represent our trials. And to start, I'm going to see if 10 boxes will do the trick. So I'm going to copy this formula and then go down 20 rows across 10 columns. You can see up by the formula bar that it says 20 rows by 10 columns, and then I'm going to paste. And so we've got this mishmash of random numbers from 1 to 4, which is great. Now, as I said, these are formulas that recalculate every time you do a new calculation, and we don't want them to recalculate, we want them to be fixed. So I'm going to leave my formula in A1, but the rest of these we're going to change from formulas into values. And the way that you do that is to go to Edit Copy, and then Edit Paste Special. Values, we're changing formulas to values. When we do that, and then click on this 4 up in the formula bar shows up as a 4 now, not as the function rand between. All right, so we've run these trials. We do need to decide, perhaps it would have been better to decide ahead of time, which card number is our goal. My goal is going to be card number 2. I'm going to format this just slightly so that it's clear that my goal is card 2. And so I'm interested in card 2. Conveniently enough, in this first trial, it looks as if I chose 10 boxes and didn't get my desired card. Perhaps not the luckiest of players of this game. But anyway, we're going to do a formula, and we're going to address that issue in a moment. But we're going to do a formula that looks for the first occurrence of the number 2 in each trial. So in order to do that, we want to match. So that's equals, again, a function. The match function is what I want to use. Functions show up here on the function list. And when you click on match, it tells you what you need. A lookup value. My lookup value is 2. I could have changed that goal, so I'm going to go ahead and, rather than typing in 2, I'm going to use M1 as my goal. Where am I looking that up? That's the lookup array. I'm looking for that number there. And if I put in 0 as the match type, it'll return the first occurrence of the number 2. So when I do that, I get NA, because lo and behold, I didn't get a 2. So if that is a possibility, what that says is 10 boxes wasn't enough. So I'm going to go ahead and insert 5 more columns. I don't know if 5 will be enough, but we'll give it a shot. You can, of course, start with more columns if you think that it's a waste of time to have to add. And I've got my formula back in here, so I can still copy this. Sorry, that's Edit Copy, and paste it into these 5 columns and see if we get the desired result. We'll paste it. Then, of course, we have to copy and paste special to values to get there. And now our answer hasn't changed, but that's because our answer refers to J2 when in fact we've now expanded our trial all the way over to column O. So we need to change that J to an O. And we can do that here in the, and you can see the green box that shows you that you've captured it. And as you can see, it was a 12th box. That it took me till the 12th box to get my desired card number 2. Now, of course, in the real trial, we would just ignore the 13th, 14th, and 15th box because my goal was to get my treasured card. Now we want to do that for each of these trials, so we could copy down, but we're going to run into a problem there, a different type of problem, when we copy this down. If we get NA here, it may or may not be because we are missing a box, but the key issue is this refers to R2, while our goal is actually in R1. That's called a relative reference. We need an absolute reference, so we go back up to the original formula, and we want to put a $sign in front of that 1 to hold it. So if we put a $sign there, now when we copy down, let's see if it's still NA. It is not. In fact, I don't have any NAs. It looks like my first trial was my worst trial. So we don't have any NAs, so it looks like our trials have been successful. In each trial, we've managed to eventually find card number 2. Once our trials are successful, we want to go ahead and make a frequency table that will enable us to move on to probability distributions and experimental probability distribution. So let's do that. That's a number of boxes required to find the card, and the frequency. How many times did it take that many boxes? We'll go ahead and center these two columns so that our output looks nice and pretty. We can see that the most boxes actually was that first try when it took 12. So I need the least possible boxes is 1. So I'll go ahead and make a frequency table, and I'll go ahead and consider the possibility that it might take me all the way down to 15. Now, of course, we can count these up. It's not, it would be a little bit of a hassle, but it's certainly doable in a case of 20 trials. But later you're going to be doing 200 trials, and that makes it a little more of a challenging task. So better to have the computer do it for us. If we want to count the number of times that we got it on the first box, that we will do with the COUNTIF function. Equals COUNTIF. It takes a range first. That's the range. We want to find our value in that range, and although it's blocked out here, it's S2. It contains our desired number. Rather than put in 1, because if we put in 1, when we copy it down, we'll always be looking for the occurrence of 1. Whereas if we copy this down, this relative reference will work to our advantage. When we copy it down one column or one row, it will refer to S3. So in 5 times, does that seem particularly lucky to you? I'm not sure. And then if we wanted to copy this down, before we copy it down, we need to realize that we want this Q2 to Q21 to stay the same as we copy down. So we're going to add $signs there as well. Copy this down, and it gives us our frequencies for each of those number of boxes. That's probably pretty good. As an extra check, especially when you're doing the 200 trial case, might be a good idea to sum and see that, okay, we did in fact capture all 20 in our frequency table here. From here, you can move on to a probability distribution. That's not hard, but this is how you do a simulation using random numbers in Excel.